Okay, just going to look at three-dimensional trigonometry. We're going to look at where the H is on the tower. And what you've got to do is be able to bring the H from the tower, bring it down to ground level. Now, I'll show you what we mean as we go through this. So, if we're going to look at this question, first it says the angle of elevation of the tower from A is 42. So let's just write down what we got. The angle of elevation of the tower from A equals 42 degrees. And B, the angle of elevation of the tower is equal to 30 degrees. Okay, so we know if we look at the bearings, so the bearing of A is 120 and B is 200 from the foot of the tower. So if we were looking at this, we're looking at it as a bearing. If that was the foot of the tower, we'll call that T, or the bottom of the tower, the bearing of A is 120 and the bearing of B is going to be 200 degrees. That's going to be 200. So that's B. So this angle, BTA, where T is the foot of the tower, this angle will be equal to 200 minus 120, which is equal to 80 degrees, which is what we meant to show here. See the 80 degrees. So show that angle ATB equals 80. So that angle in there is 80 degrees because it's basically equals the 200 minus the 120. So what that means is we've got this tower sitting here now, and we know a couple of things. We know from if we've got our tower and we draw our right angle triangle here. No, wait a minute. Let's get rid of that. I'm going to draw it like a little triangular prism like that. We know that that's T, that's A, and that's B. Okay. We then know that this here is equal to 80 degrees because that was that angle we just found. These will be right angles here. That's T there. They're right angles because when you're looking at this diagram, the bottom part here, that there is the base of the tower. And then we have these parts here. So we have this one here. That there is one of the triangles on the sides. And this here is the other triangle on the side. Now, the foot of the tower, this part here, the foot of the tower is T. So this foot of the tower here is T. The top of the tower is C. Okay, so that's the height of the tower there. Okay, and now what we need to do is, this is T and this is TA and TB. We need to find what TB is in terms of H. So if we redraw that triangle and we make it flat, that's H, that's C, that's T, and that's B. So what we're interested in finding is TB, which is this one here. Now, let's see, that's TB along there. So we know that the angle in here is equal to the angle of elevation. So they said the angle of elevation of that one from B is 30 and from A is 42. So that means that angle in there is 30. So now if you look at trigonometry, that would be opposite. And BT here, that would be your adjacent. So that means that tan 30 equals O opposite, which is the H, over the adjacent, which is BT. So all we've got to do now is rearrange that. So that's BT times tan 30 equals H. So BT equals H over tan 30. So now if we go to this one here, we go tan 42, because what we're going to do is going to have this triangle here. This is 42. That's H, okay? And this one here, this is what we're going to find. This is TA. So tan 42 equals h over TA. So TA equals h over tan 42. Okay. All right, so looking at that gets us the answer to part 2. Now, the last part is to actually find out what h is. So what we do with all this information is we take the triangle that's at the bottom, this one here, and that triangle is equal to BAT. This angle in here is 80. Now, we just found out that BT was h over tan 30, and TA is h over tan 42. And what we want to do, we know that this here is 400, okay? Because we got the distance between A and B. If you look back at the question, distance between A and B is 400. That's where they say it up here, okay? You see the 400. So the distance between A and B in the question is 400. So we've got that distance, we've got the bearings 120, 200, and the angle of elevations from A is 42 and from B is 30. Okay, so what are we going to do now? So if you look at this looks a lot like the cosine rule because there is one angle. So we start off, and the cosine rule says c squared is a squared plus b squared minus 2ab cos c. So that means 400 squared equals h on tan 30 squared plus h on tan 42 squared minus 2 times h on tan 30 times h on tan 42, and then it will be times cos 80. So times cos 80. Okay. So 400 squared equals, so that's h squared on tan 30 squared plus h squared on tan 42 squared minus 2 times h is 2h squared cos 80 all over tan 30 tan 42. That's on the bottom. So what we do now is we go through and we look for the common factor, because there is a common factor of h squared, and you need to take that out. So you go, all right, that's 400 squared equals h squared, and we have 1 over tan 30 squared plus 1 over tan 42 squared minus, so take the h squared out, and this is what you've got left after you've taken the h squared out. Sorry, I meant to do that as this one. There's your h squared. So what you have left here now is this. And what we're going to do is bring it to the other side and do division. Because now you would have h squared, I'll just say h squared equals 400 squared divided by all this stuff that is in the bracket. So that's 1 over tan 30 squared plus 1 over tan 40 squared minus 2 times 1 over tan 30 times 1 over tan 42 times cos 80. So h equals the square root of whatever that answer is. Okay, so when you work out, they get the square root of 138.058, and I get 11.75. Sorry, just recalculated it. It should be, this time I got that answer under the square root as 112 0.189, and then when you square root your answer, I get 10 point. So you get 10.59. So as the height of the tower.